In this video, I will be showing you how to evaluate seemingly difficult logs mentally, how to do that mentally. These are examples of seemingly difficult log. They appear difficult, but I will show you that they are not really difficult to evaluate mentally. So first, let's look at some easy ones before we go to these more difficult ones. So easy ones, like for example, if I give you a log, like log, let's change that. So log, for example, log base 2 of 16. Well, I know that 2 to the power of 4 equals 16. So the answer is 4. That's easy, okay? Or I give you log base 5, let's say base 5 of 25. Well, I know that 5 squared, let me rewrite that, sorry about that. Log base 5 of 25, so I know that 5 squared is 25, so basically the answer is 2, because logarithm of a number is the power to which you raise the base. So the power to which you need to raise this base to get 16. So the answer is 4. The same thing here, the power to which you must raise 5 to get 25. The answer is 2. All right. Now, those are easy, direct ones that are very easy to do. Now, when you come to logs like the log to base of 1/5 of 1/25th, or of the base of 1/25th of 1/5, and many other ones, they may appear difficult, but I want to show you that they are not really hard to understand, to figure out. Okay, let's start with easy one first from the difficult set. Okay, so if I give you log base 5 of 125, number 1 on this example, well, I'm looking for some number I'm going to use with 5 as, as exponent of 5. That will give me 125. Well, I don't know. Well, if I know that 5 to the power of 1 is 5, 5 to the power of 2 is 25. Well, 5 to the power of 3 is 125. So the answer is 3, which is the power to which I must raise 5 to get 125. So the answer is 3 here. That's sort of like not too hard to understand. Okay. Now, but if I reverse it and give you the log of, maybe if I make it bigger might be better, like here. Okay. So if I give you the log of log base 1/25th of 5, base 125 of 5. So you will be thinking in your mind, what should I raise 1/25th to get 5? You're saying, well, I don't know, what am I going to use as a power, the exponent for 1/25th that will give me 5. So now you see I'm going from a big number to a small number. Unlike the other one, I was going from a small number to a big number here. So I know I need power here. I need power. I need power to go from smaller number to bigger number. But if I'm going to go from bigger number to smaller number, I don't need power like integer power. I need root. I need root. So I need to take some kind of root. So, and now I begin to think to myself, should I take square root of 125? Will that work? Square root of 125. We know 125 is not a perfect square, so that's not going to work. So that's square root. The next thing I'm going to think now is, what about cube root of 125? Yeah, I know that cube root of 125 is 5. So I need to, because 5 times 5 times 5 is 125. So 5 cubed is 125. Therefore, I need the cube root of 125. I need this to get to 5. Now, the next thing I'm going to think to myself is that, well, how do I write cube root as an exponent? Because logarithm is an exponent. I need an exponent, all right? I don't need root. Well, I'm going to remember that root can be written as exponent like this. So the general rule that we know is that if I have the nth root of x is the same thing as x to the power of 1 over n. That is an important property that everyone knows, or we should know, that the nth root of x is x to the power of 1 over n. So the cube root of 125, the cube root of 125 is really 125 to the power of 1/3. So that means the root, I need the root, cube root of 125, so or to get 5. So maybe 1/3 is the exponent I'm going to use. So, summary of what I've been trying to say to you or try to teach here is that if I'm going to go from 5 to 125, I need a power. I need some integer power. But if I'm going to go from 125 to 5, I need some fraction power. Fraction that is less than 1. I need that. So it's 1/3. We'll see more example later on. Maybe I should just give one example right here that is not written here. Here's another one. If I give you what is the log base 64 of 4. Well, I'm going to go from 64 with some power to get 4. This is big. 64 is bigger than 4. So I need to take some root of 64. And the only thing I can do is the cube root of 64. Cube root of 64 is 4 because 4 cubed is 64. So I need cube root, which is the same thing as 1/3. All right. So let me write another example right here. If I have log base 49 of 7, well, I'm going to go from 49 to 7. I need to take root. Here, it's clear that square root of 49 is 7. So I need to do square root. And square root, according to this rule right here, square root is some number to the power of 1/2. So the answer to this is 1/2. Okay, so basically we can just understand that going from smaller number to bigger number, you need power. That is, you need a power that's integer, that's bigger than 1 or more, okay? But going from bigger number to smaller number, you need a fractional exponent. All right. Now, let's look at number 3 on this page. Number 3 on this page. So this time we're going to find the log to the base of a fraction that will give me another fraction. Well, it's still the same principle. I'm going to go from 1/5 to 1/25. If I focus only at this number down here, just focus on this 5 and 125. Disregard the 1 for right now. Well, I know I'm going to have to go from smaller to bigger. I go from smaller to bigger, just the denominator alone. So I need some power that is more than 1. So 5 cubed will get me to 125. Now, so because they are both fractions, then the answer to this will just be 3. I want to prove to you that it's just 3, the same thing, just looking at the denominator. Let's prove it. That is 3. So we can do 1/5 to 3rd power. That's what we're saying. So it will be 1 cubed and 5 cubed if you separate the numerator and denominator. 1 cubed is 1 and 5 cubed is 125. So So the same principle applies. If you focus just on the denominator, that you only need you need a power that is greater than 1. All right. Next, let's go to number 4. Number 4. I'm going to go from, I'm looking for the log base 125th, base 125th of 1/5. Well, like I said, let's focus just on the denominator at this time, just the denominator. So 125, I'm going to 5. Well, like before, like in number 2, you're going to take cube root. So cube root of 125 is 5. So the answer here has to be 1/3. If you focus just on the denominator. Well, let's see if it works or not. Let's try to do that. Check it. 125, 1 over 125 to the power of 1/3. Well, I'm going to separate them into numerator and denominator. 1 to the power of 1/3 divided by 125 to the power of 1/3. Okay? So 1 to the 1/3 is just 1. 1 to the power of anything is 1, okay? And then the cube root of 125 is 5. So it works. So we got that. It works. All right. We go to the next one, number 5. I want to do the log to base 125 of 1/5. Here, the fraction is only one of the numbers is a fraction, the other one is not. Well, I'm still going to focus on the denominator, okay? Well, the two numbers. I'm going to focus on 125 and 5. So 125 is going to become 5. So that still looks like number 2. It looks like this number 2 that we're working on. So we need root. We need cube root. So cube root of 125. We need cube root still. So cube root of 125 is 5. So we need cube root. Now I want to write the answer as cube root. Cube root 1/3. All right. But wait a minute. Let's check to see if it's true or not true. Let's check. If I put 1/3, 125 to the power of 1/3, the answer is just 5. Not 1. It's not 1/5. So I need to do something to turn 5 to 1/5. Well, if you have been following the lesson previously, we know that if I use -1, if I do 5 to the power of -1, I'll get 1/5. So I need to put -1 with my exponent. So that's why it's not just 1/3, but it's -1/3. All right, it's -1/3 because I need to do -1 to get 1/5. So I'm going to write the proof below here. The proof is that I need 1/25 to be raised to the power of -1/3 in order to get 1/5. All right, so the same thing here. I'm going to go from 125, number 6. I'm going to go from 125. I'm going to go to 5. I still need cube root. I need cube root also. So the answer will be 1/3. The answer is 1/3 right here. But if I do 1/3, 125 to the power of 1/3, I only get 1 over 125 to the power of 1/3. Sorry about that. Let me rewrite it. If I do 1 over 125, little bit hungry, to the power of 1/3, well, that will be 1 over 5, right? But the answer I'm looking for is 5. So I need to do something to 1 over 5 to get it to 5. So if I raise that to -1, that will be 5 because I flipped the number. So I need to put a negative with my answer. All right. So now I'm ready to summarize all of these results. Let's remove all the other marks and summarize the results. Okay, there's a pattern here. Let's look at all these 6 examples. There's a pattern here. All right, when both numbers, when I'm going from smaller number, number one, smaller number to bigger number, I need a number that is bigger than 1 as a power. Okay, we got that. If the number is bigger at the base of the log, then I need a root. Okay. If they're both fractions, I will end up with a positive number, focusing just on the denominator alone, going from 5 to 125. I need 3, but it will be positive because they are both fractions. See, when they are both fractions and I'm going from 125 to 5 is 1/3. All right, and I don't need a negative. But if one of the numbers, the base or the argument, is a fraction, I just need one of them to be a fraction, and then I'll get a negative answer. See, one of them is a fraction, I get a negative answer. So basically, that's what you do. I'll give an example of another one that is not 125. Let's just give one like for example, log base 1/81 of 3. Okay, now I'm going to go from 81 to 3. I'm going to go from 81, if I look at the denominator alone, 81 to 3. I need root. So the root of I need 4th root. I don't need cube root. I need 4th root. So 4th root of 81 will get me to 3. All right, so then I know I need 1/4 here. But one of the numbers is a fraction. The other one is a whole number. So my answer will not just be 1/4. It will be negative 1/4. So the answer to this is negative 1/4. All right, so I can prove it by doing raising 1/81 to the power of negative 1/4. Then I need to flip the inside. That will be 81 to the power of 1/4 and take away the negative. And then the 4th root of 81 is just 3. So it works. Just looking only at the denominator whenever there are 2 fractions or 1 fraction, and determining if you're going to be going from bigger number to a smaller number. Well, I hope this works. There are several other examples I wanted to show, but the video is getting very long. I wanted to show you other types of more difficult problem like the one on this screen right here. So, but I will show it on another video and call it part 2. So look out for part 2 to be able to get information to this kind of fractions, logarithm in which the numbers, the bases don't match.